All right, so still on lecture series number 7, which is model implementation using machine learning. So we've got into a stage where we have an understanding of what this whole notion of machine learning is all about, and specifically its role insofar as pattern recognition is concerned. Key takeaway point from our discussions is this whole notion of the mathematical function y is equal to fx, right? Where your x is composed of independent variables that make up the different data attributes associated with the data you're working with, and the y will be the labels that you're interested in predicting. And also, what we did in the previous screencast is we walked through the 3 different broad categories of machine learning techniques. So supervised machine learning, unsupervised machine learning, and so-called semi-supervised or reinforcement learning. And we went through a series of examples to help us get an appreciation of these different categories of machine learning. Hopefully that was useful. We even went so far as to try and identify aspects of talks that have been given as part of the seminar series for 5741 to try and underscore this whole notion of machine learning. But before we start, right, on the evaluation part, I thought I would share some other examples that I've experienced, examples of things that we typically work with most of the time. So I don't know how many of you actually produce content for YouTube, but what you probably notice is that if you do that, one of the obvious things that you'll notice is that there are some comments that are clearly associated with bots, right? And it's usually the case that these comments will have little or nothing to do with the video that you'd have uploaded, for instance. So every time I upload a new video on YouTube, I will almost always have these random comments. So clearly I can see from these comments, for instance, when I got this snapshot here, it's coming from the so-called Logan character. It's a bot, right? Because the same Logan has a different image here. And it's almost always the case that this Logan character or this Logan account will post more or less the same comment text, right? The same goes for this, right? Clearly. It's so, you can tell that this particular comment is so generic. It can be applied to typically any YouTube video here. This would be one of your best. I mean, what does that even mean, right? You are really talented. It's like they're trying to bait you into liking that comment if you're not smart enough, if you're not knowledgeable with these things. To try and bait you into liking that comment. And what that does really is that when you like a comment or when you respond to a comment, it's probably going to be ranked much higher on your it's going to be ranked higher relative to the other comments associated with that video. And obviously if the comment is rated higher, then it's likely going to appear on the top, right? On the top of the comments list. If that's the case, more people are likely to see it. When more people are likely to see it, some of them will be curious enough to find out who this or which account this is. I do that a lot myself. When you do that, you're being baited into visiting that particular YouTube channel, right? So I thought I'd mention that. Of course, some comments are clearly associated with the video, right? I mean, look at this. This comment is nothing more than a link to some really questionable site here, sexygirls-here.online, right? Virtual chat girls online, right? So, but the key thing though is that it turns out that this can be viewed as being a machine learning problem, right? And I'll go to YouTube. Can I go to YouTube? I'll go to YouTube Studio and then I'll go to my comment section. Then, right? Once I get, I didn't know about smart replies here. This is interesting. This is another new thing. I didn't know about smart replies. I'm just seeing this right now, by the way. Beautiful. Okay. The thing with such replies, like the reply on Knox talk, right? It's this comment. It's David Lee now. His comment is and whoever the people coming up with these bots are pretty smart, right? So they're they are, as part of the comment, they identify, I guess this is like some random timeline in the video, right, to try and bait you into clicking on the link, right? This is probably just randomly generated here. You can see it's randomly generated because the name Kenneth Martinez here has a different randomly generated timeline, but pointing to a different website, probably a suspicious website here. But key thing here I wanted to point out is that you can train whatever model is being used to do this, can be trained. And look at this. Loved it, and someone even liked this comment, right? You can actually hide or remove the comment, or you can mark it as spam. What I do is I don't remove the comments, but I mark them as spam. I mark them as spam so that where's approve? I mark them as spam, and if only I can identify something that I haven't yet marked. If I was to, I could easily have marked, you know. You can mark them as spam, right? In which case you're implicitly training the model actually. It's kind of, oh, I didn't know this was commented here. Beautiful. Okay, so yet another classic example where machine learning is at play here, right? I use it a lot where you're training the model to say, when you look at something like this, report it as spam. So if I come here, I would say report this. When I report this, I'll just say this is it's unwanted commercial or spam, and then I'll report it. And it's going to be excluded from, it will be hidden from the comments section. But also what I'm doing implicitly is I'm training the YouTube algorithm, as it's commonly referred to say, when this David Lee account is used again elsewhere, and if the piece of text associated with the comment is more or less the same, then it's likely spam, right? Which is why sometimes YouTube will automatically detect that something is likely spam. If you look at this, if you look at the published comments held for review, and then there are comments that are, this is, oh, bro, I need to get in touch with you. I guess this is not likely spam. I didn't see, this is an old one. It's held for review, but there are some comments that are classic. They're identified by the YouTube algorithm as likely spam, right? So I don't have to I don't have to explicitly tell the algorithm, say this is spam. It's already been classified as being a spam comment, right? And it's likely the case that the identification is tied to the text representation of the comment text, right? So this URL, for instance, freedating18.online, you know, because if you notice, these people are so smart enough that they, oh, but this is not spam. Dynamic libraries. I don't know what this is. These are old comments though. Some of these are quite old. I don't know what this is. I don't know what the hell this is. It's in Spanish. Translate. Ooh, I hope I'm recording this. Yes, I am. Hail Mary, full of grace. What the hell? So clearly spam, right? I'm not interested in the Hail Mary, not right now anyway. But I suppose on my deathbed I would be. But this is a thing here, right? Classic examples, more classic examples of supervised machine learning. Classification of comments as being spam or not spam, likely spam. Should a comment be held for review or should it not be held for review, right? Great. So another example I wanted to point you at is if you use YouTube, what you probably will have noticed is that if you use a lot of YouTube, I think most people spend time on YouTube, is when you're watching a video, there are some recommended videos that will normally pop up, right? In this case, so this snapshot that I got here, by the way, was my mobile device. Somewhere below here will be like related videos, right? And these related videos, it turns out if you pay particular attention to how this is generated, the related videos are tied to your watch history, in part to your watch history. So for instance, in this case, I was watching Mick Mills' I'm a Boss or something, right? But I'm not a boss, but I was just watching it anyway. But you notice that some of the videos that were recommended are videos that I've watched in the past, and it's likely that the sequence or the way that I was watching the videos in the past was in such a way that this video called I'm a Boss was watched maybe after or before I watched Wale's Ambition, right? Which is why this is recommended. Yeah. They're even recommending these other videos. And notice some recommendations are based on your watch history. Some recommendations are based on the artist, right? Some recommendations are likely based on the tags associated with the video, because it turns out that when you're publishing a video, and I'm uploading a video just now, which is CSC 5741, by the way. When you're publishing a video, when you're uploading it, you provide certain key markers to the video. So the description in the text, the title, right? The title can be viewed as the text representation of the title can be used as X. The text representation in the description can be used as input features, as your X, as your independent variable. Not only that, the location, right? Because one of the things you do when you're uploading a video is you specify which location is being uploaded from, right? In my case, it's always University of Zambia. University of Zambia is in Zambia, right? So that can be used as an input feature. But also things like tags, right? One of the things you do as well is you specify tags. This thing is taking a bit of time. Why? You specify tags. So we can just go down to the video here. So text representation, image, text, the representation, the text in the title, the text in the description, the text in the, and I guess I can just close these now because they're eating up. All of this is in memory. Just close this. The text in the description, but also one of the things you do is you specify tags, right, to the video. So these tags would be used as input features as well. And if you think about this, when you're building a model, you can build a model that looks at these different attributes independently, or you use a combination of these different attributes. So you combine the title, the description, and the tags, and see what sort of effect that would have. All right, great. So we immediately transition to the next part where we start looking at the model evaluation process. I hope I'm still recording. It would be sad if I'd have to start this from scratch. So once you implement your model, obviously, one of the obvious things you need to do is you need to assess its relative usefulness, its relative value or worth, as they say, right? And so you'd have to evaluate the model. Evaluation is centered around you coming up with a judgment that's associated with the relative value or worth of whatever it is you're doing. In this case, the model implementation, what sort of value does it have? What is its relative worth? And if you think about it, value and worth are directly associated with your objective. Why is it that you're building that particular machine learning model in the first place, right? And so you are evaluating it against the objective or the goal, right? Some key things to note about evaluation is the evaluation process is meant to be systematic and it should be rigorous. Systematic meaning that it has to be done in a certain prescribed manner. And one of the reasons we do that is to ensure that the whole process can be replicated. The whole process can be reproduced, right? It should be reproducible. So if you build a model and evaluate it, you get a 95% accuracy, for instance. A different person should be able to follow through with the steps and the procedures that you followed, and they should be able to get the exact, or at least a value that is somewhat closer to the accuracy, which is 95 in this case, right? So it has to be systematic and rigorous. And you notice that this whole notion of it being systematic and rigorous is really associated with so many different aspects here. But we'll get to that very soon. And hopefully you've picked up on some of these things as we're reading up on those paper readings, right? And usually the evaluation would assess the set of objectives. So, and I always like giving this example. A person could ask you to say, how effective is Lighton at teaching 5741, for instance? What you'd be doing is thinking about specific metrics or specific aspects that you'd use to evaluate the effectiveness of Lighton in teaching CSC 5741. And really, there's different aspects if you think about it, right? So how well does he deliver the content when he's giving a lecture, when he's creating a screencast, for instance? How well does he interact with the students, right? How fair is he when it comes to assessments, right? Those are all different ways of, I guess, measuring how effective Lighton is, right? Key takeaway point here is this thing here would be loosely tied to the objective, right? The evaluation itself. And once you identify an aspect of evaluation that you're interested in, then you settle on the specific metrics that you're going to measure, right? So if you're saying you're interested in measuring the effectiveness of Lighton, for instance, you identify things that you're going to use to assess the effectiveness of Lighton. Those would be your metrics. More on that shortly. So metrics would be attributes that will provide you the measurable that you use to assess the implemented model against the objective. So you have an objective that you set aside as you initiate this data mining activity. You have a set of objectives, right? You come up with a plan, and then as part of the evaluation, the metrics that you come up with would need to take into account the goals and objectives or the task at hand. But it turns out really that evaluation, beyond this, evaluation is extremely important, and its contextual, its importance is contextual. It's dependent on the type of problem that is being addressed. There are some problems that are really critical, right? They can determine whether or not someone lives or dies. And this is usually the case for, I guess, domains such as health, for instance. And in this image, for instance, the aviation industry. I don't know how much of this, the Boeing 737 MAX issue you remember, but there's an issue. It turns out it's a software issue here. So one way of looking at why the problem could have occurred is because someone slacked. Someone did not pay particular attention to the evaluation process, right? Because if the evaluation of this Boeing 737 MAX was systematic and rigorous, they would have been able to figure out the problem before it actually happened, right? If you look at this is slide number 35. If you look at application of machine learning in health, for instance, this is serious, right? This is serious because if you build a model that doesn't properly or accurately determine the problem that's afflicting a particular patient, it's likely the case that that person might eventually succumb to the illness. So let's say you build a model that's meant to detect whether or not someone has testicular cancer or some weird problem like that, or maybe not cancer, but yeah, well, maybe throat cancer or something. And so it happens that there's a flaw in the model, right? And because the evaluation process was not rigorous enough, what might end up happening is that the model will end up not predicting that someone likely has cancer, in which case the problem will probably, or the cancer will probably anesthetize, then eventually the patient might probably die or something, right? So key takeaway point here is that some domains are extremely sensitive, and so careful attention needs to be placed when conducting your evaluation or the evaluation of these learning algorithms. Of course, I mean, some domains are not really that, they're not, it can't really be associated with health risks, but there's a social aspect associated with them. We always make mention of this this example here. Someone tweeted a Google Photos. Someone tweeted how Google Photos actually classified a photo of him and a friend as being gorillas, right? When in actual fact they're human beings, and there was an uproar here, right? A lot of people speaking against Google Photos. It turns out it was a flaw in the model that was implemented to automatically classify the different images in one's Google Photos library. I don't know how many of you use Google Photos, but a very nifty, very nifty application. I use it all the time because I use Android a lot myself. Been using Android for years actually. But the key thing here is one of the things it does is actually, or one of the things it probably does is just identify faces, for instance. And in this case, I think one of the area visions was identifying categories associated with different photos. So it's vehicles, graduation, bikes, and whatnot. But because this is an automated process, you notice that errors do happen, right? No model could be 100% correct here. But another implication of this particular example is that there's a social aspect to it, right? Of course, for some, and if you want, you can think of a part that is perhaps a part that might have a social aspect and is sensitive as well, is this example that we've been using, classifying whether a student is at risk or not at risk, right? If you think about it, if we built a model that was not rigorously evaluated, a model that is meant to identify at-risk students, and it turns out not to identify a student who is at risk, then the planned intervention would not involve or incorporate that student. The likely outcome would be that the student would probably end up failing because the intervention would not be exposed to the student, right? But of course, I mean, it turns out that there are certain areas where if the model ends up not predicting the correct thing, the results are not really as adverse as some of these areas or domains, right? So a classic example would be search, right? When you're searching in Google, one of the things that that Google would typically take into account is if I say University of Zambia, for instance, right, and say enter. One of the things Google takes into account is obviously my search history, right? Because I'm logged on right now, and I always log in, by the way. Unless if I don't have to, in which case I'll use an incognito window, but I suppose you know this anyway. But something else that Google does is they'll take into account your location, right? So what I'm trying to get at here, what I'm trying to hint at is that the SRP, right, the search result page that is exposed to me, this paginated search result page here, is personalized in such a way that it takes in so many different variables. Where I'm currently searching from, my past search history. And in as much as a search user, I would want these results to be relevant relative to the query that I've issued, the implications of Google bringing up search result pages that have little to do with my search are not as adverse, right? Because all I would do is maybe if the first SRP doesn't have what I want, I can easily go to the next one, second one. If the second one still doesn't have what I want, then I will probably review my query and then reissue the query. At the very least, I'm spending more time trying to find whatever it is I'm looking for, that would be the implication of this particular domain, right? Compare and contrast with other domains that are extremely sensitive here. Health, right? Aviation industry, the financial sector, when you're dealing with money, right? If you think about Knox talk, for instance, if he was to deploy his model, which is able to cluster potential fraud happening at NatSev. If you think about this, if there's something wrong with his clustering technique, then it's likely that they'll not be able to pick up all the potential accounts that are associated with fraud, right? In which case the company will continue losing money, right? Very serious implication. So the financial sector, the health sector, transportation, right? With these self-driven vehicles these days. All right. Hopefully that kind of helps contextualize evaluation. Let me see time here. Probably pause for a little while and then we'll continue off with evaluation aspects in the next screencast.